Which of these objects is moving faster? Most people would say the blue object is moving faster because it has to cover more distance in the same amount of time. We might also say that both objects are moving at the same rate if we consider that they're taking the same amount of time to go around the circle. So we have two different ways to describe circular velocity. Normally we describe velocity as being the change in distance over change in time, which we can abbreviate as delta d over delta t. In this case, for this illustration, it's taking about 4 seconds to go around the circle. If we consider the red object, the distance it has to travel is the circumference of the inner circle, which is 2 pi times r, and r is 1 meter. This gives us a distance of 2 pi meters, and we divide that by the 4 seconds and get pi over 2 meters per second of velocity. If we do the same thing with the blue object, we see that it's going 6 pi meters. And so if we divide that by 4 seconds, we get 3 pi over 2 meters per second. The blue object is indeed traveling 3 times faster than the red object. This is what we call linear speed or linear velocity. So even though it's going in a circle, which really isn't a straight line, we still refer to it as linear speed. It's the speed that the object travels along the circular path, which is the circumference. If you look at the formula that's in yellow, you'll see the circumference, 2 pi r, on top, and we're dividing by time on the bottom. That's just distance over time. If instead we look at how long it's taking to go around one revolution, in other words, how fast is this entire object spinning, we might be looking at the change in the angle over time rather than the change in the distance. This is what we call angular velocity. So just like we had linear velocity, which is distance changing over time, angular velocity tells us how much the angle changes over time. A familiar unit that we see in angular velocity every day is called the RPM, revolutions per minute. However, the standard unit in math and physics is radians per second. So recall that a radian is a measure of an angle, and so it's telling us how much angle the object is going through in a certain amount of time. We use a lowercase omega, Greek letter omega, which looks kind of like a curly W, but it's actually called omega, as the symbol. We can convert from RPMs to radians per second pretty easily. If we consider that 1 revolution per minute is 2 pi radians per minute, since there's 2 pi radians in a revolution, 1 minute is 60 seconds, and then just simplify the expression, we find out that 1 RPM is the same as pi over 30 radians per second. If we know the linear velocity, we can find the angular velocity, and vice versa. We have two formulas that relate the two quantities to each other. Really, they're the same formula, just solved for the two different quantities. Okay, so let's take a look at a summary here. And right here we have a summary of the formulas and some notes. Okay, so v is the velocity, which is the linear speed along the circumference. How fast is the car going around the track, if you will. Omega is the angular speed, which we might use RPMs or radians per second. R is the radius of the circular motion. And then we have equations, formulas. Omega is the velocity divided by the radius. Velocity is omega times the radius. Velocity is also the distance, 2 pi r, divided by the time. We can convert 1 RPM into either 2 pi radians per minute or pi over 30 radians per second. Let's take a look at a couple of examples. Number 1, an object moves in a circular path of radius r equals 5 meters at a speed along the path of 37 meters per second. Find omega. We're going to use the omega formula that takes velocity and radius because we have both of those quantities. Now it's important to note that in this case our units are consistent. We're dealing with meters in both cases. So we have 37 meters per second divided by 5 meters gives us 7.4 radians per second. A 12-inch diameter wheel rotates at 5 RPM. How fast in inches per second is a point on the wheel's edge moving? So we're talking about linear velocity. The point is moving around the circular edge. And we have a measurement of angular velocity, but it's in RPM. And so what we're going to do is change our RPM into radians per second by multiplying the RPMs times pi over 30. Also notice that our radius is 6 inches because we are given diameter. So 12-inch diameter gives us 12 divided by 2, or 6 inches of radius. When we go ahead and put all of those together, we get pi inches per second. Number 3, we have a car that takes 3 minutes to drive around a circular track that's 1 mile in diameter. So the question is, how fast in miles per hour is the car moving? So in this case, we've got mixed units. We're asking for an answer with hours, and we have time given in minutes. Our track distance is given in miles, and we do want miles in the miles per hour. So this will be a quick example of applying dimensional analysis or conversion factors to get the answer that we need in the correct units. We're going to go ahead with velocity is the change in distance over the change in time. Again, that's the circumference of the track divided by the time it takes to go around one time. 2 pi r, remember that r is half of the diameter, and so we have basically a half a mile here. And then we have a time of 3 minutes. Now, we want our answer to be in miles per hour, not miles per minute, so we're going to put a conversion factor here where we're going to basically cancel out the minutes and leave with hours on the bottom. So we put minutes on top, hours on the bottom. 60 minutes equals 1 hour. Now we just multiply across the top, multiply across the bottom, and divide, and we get our answer of about 63 miles per hour.